So here we are, notes for 2-7 algebra, simplifying radicals, looking at example 3. So example 3 is a little bit different from our first two examples because I have not only a number on the inside of the radical, but I also have something on the outside of the radical. So don't freak out, just remind yourself that the operation going on here is multiplication. You know, that -3 is not attached to that square root of 972. They are just simply being multiplied by each other. So that -3 isn't really going to do anything until I get down to the end more. So just like in our previous problems, I'm going to start off with my calculator looking for factors of 972. And not only just factors, but also perfect square factors, more importantly. And I'm just double checking to make sure I put the right number in because we've all done something like that before. Second, and graph to get to my table. Okay, so 2 and 4 is 86. So 2 and 4, 86. 3 and 3, 24. 4 and 2, 43. Holy moly, I feel like this is going to be a long. 6 and 1, 62. 9 and 108. Ooh, 12 and 81. 12 and 81 is definitely a good possibility because I know 81 is a perfect square. And this is where, like, if you memorize some of those perfect squares, it's going to be coming in handy. 18 and 54, I don't know. It's not really going to help us, I don't think. 27 and 36. So that's, I'm going to stop there because even though 36 is a perfect square, 81 is a larger perfect square than that. So I'll choose 81. But really what I should do is I should go through my calculator and make sure that none of these other numbers are perfect squares. But we'll see what happens when we do that. So again, that -3 is just being multiplied, so I'm just keeping that on the outside. I'm going to break up the square root of 972 into the square root of 81 times the square root of 12. -3, the square root of 81 comes out as 9. Notice the way I'm keeping that multiplication there. I did not turn that into a -39. And then the square root of 12. 9 times -3 is -27. I can do that now because that 9 is no longer under a radical. Whereas before, that -3 can't be multiplied by something under the radical because it has to be under the same radical. Well, under a same index radical, or radical with the same index. But now actually, we're not really done here because 12 has perfect square factors still. Right, if we think about what we know about 12, you know, obviously 1 and 12, but that doesn't help. 2 and 6, 3 and 4. And don't let that little 4 confuse you. 4 is a perfect square. So that means that one of these other numbers was a perfect square that I just didn't recognize. We're going to go back and figure that out in a sec. So now I'm going to take this even a step further. I'm going to have my -27 on the outside, but I'm going to break up the square root of 12 into the square root of 4 times the square root of 3. The square root of 4 comes out as a nice normal 2, and my square root of 3 stays in the radical. Final simplified answer will come from doing 27 times 2, was it? I don't remember. Yep. Which is going to be a, I don't know where to write this. Let's go this way with it. A -54 square roots of 3 is my final simplest radical form answer. And so if we go back to our calculator here, I'm going to try the square root of 486 and see what that gets me. Square root 486. Nope, wasn't that one. So square root of 324. And it was that one. There is that. The square root of 324 ended up being 18. So that was really the largest one. But notice it didn't matter that I didn't get the largest one right away. I just had to realize that I had to take an additional step and break that 12 up further. So it's kind of like when you simplify a fraction. You know, if you have, let's say, 100 over 250, maybe you don't realize right away that you can divide both of those by 10 or by 5 or something. Maybe you go by 2 first and you turn it into, 50 over 125. And then maybe you do it again and you keep going. You're still going to get to that same simplified answer. It just may or may not take you extra steps or not. So